Let's take a look at 31. And 33 is very similar to 31, so after I show 31, you should be able to get 33. We got C is equal to 3.6. Now it's square root of x, but I'm going to go ahead and rewrite it as x to 1/2 plus 500. And again, that's C is equal to 3.6 square root of x plus 500. Now the part A says find the additional cost when production increases from 5 to 10. Now since it says additional costs, we're just talking about the algebra part. So what we're going to do is we'll plug in x equals 9, and we'll plug in x equals 10 into our cost function. So we've got C is equal to 3.6 times the square root of 9 plus 500. Square root of 9 is 3 plus 500. And then whatever that gives you. Now here, we got 3.6 times the square root of 10 plus 500. And just plug that in your calculator and see whatever that gives you. Now that's part A. It says find additional cost. Once we get this and this, you subtract the two. So you do this one minus this one. Now B says find the marginal cost. When they say find a marginal, then they're talking about the derivative. So we want to find the derivative of C with respect to x, which is why I put it in this form. Take our power, put it out in front, so we put the 1/2 here, and lower our power by 1. Now the 500 drops away. I'm not very good with decimals, but if you plug that in your calculator, I think it's 1.8. X to the negative 1/2. Now I'm going to take that x to negative 1/2 and move back down to the denominator. So we'll have 1.8 over x to the positive 1/2, which is going to give us 1.8 over the square root of x. Now they say find a marginal cost when x is equal to 9. So our marginal cost, what we're going to do is we're going to plug in 9 for the x, which gives us 1.8 over square root of 9 is 3. And again, not very good with those decimals, but I think that's 0.6. That's our marginal cost. And I just want you to compare that against the difference here. So that's number 31. Now you also had a question on 35. Population P can be modeled by this. Okay, so P is equal to negative 15.56 t squared plus 802.1 t plus 117. Well, my eyes aren't very good. I think that's a decimal. 117,001. Where t is a year with t equals 0 corresponding to 1980. Okay. Now part A says evaluate P for t is equal to 0, 5, 10, 15, 20, 25, and 30. And so what they're wanting us to do, I'll just do one of them. I'll plug in t is equal to 0. Is you go into the formula right here and you plug 0 in for t. So negative 15.56 times 0 squared plus 802.1 times 0 plus 117,001. Now 0 squared is 0 times negative 15.56 is 0. That drops away. 0 times 802.1 drops away. And we're left with 117,001. And then you do the same thing for the other t values. Now B says determine the population growth rate. So in B, they want us to find derivative of P with respect to t. Well, it doesn't matter if these are decimals, still the same idea. Negative 15.56 stays there. Take our power, put it out in front, lower our power by 1. 802.1 t just becomes 802.1. T drops away. And derivative of a number is 0, so that drops away. Oh, I hate decimals. 2, 1, 10, 11, 1, 11, 1, 2, 3. Maybe. That's equal to that. Plug in your calculator to make sure. Plus 802.1. Now that's part B, determine the population growth rate. Part C says evaluate population growth rate for the same values as part A. So same thing we did in part A, we plugged in those t values. We'll plug in t values here. So put in 0. So we've got negative 31.12 times 0 plus 802.1. That drops away, and that gives us 802.1. Now I realize what we're finding here. This is actually giving us the population up here in part A. This has given us the rate of growth of the population at t is equal to 0. And that was your last question.